Okay, let's start.
Okay, sir, we are actually we are going for live streaming, so it will take 1 or 2 minutes, just 1 minute.
Okay, madam.
Okay, good afternoon to everyone present here. It gives me immense pleasure to welcome eminent personalities on day 7 of Faculty Development Program on Institutional Values, Vision and Leadership. I welcome our distinguished speaker of the day, Dr. Jatinder Kumar Pradhan, Dr. Kiran Angra, Principal cum Assessment and Accreditation Ambassador, Paramarsh, various principals of Menti colleges, my friends and colleagues of Menti colleges, NAC coordinator Mrs. Mishu Bansal, my cherished IQAC and NAC team, and other dignitaries present here. Dear friends, we have joined together under Paramarsh scheme of UGC to reflect upon the most important feature of NAC, that is e-waste management. I feel overjoyed and my gratitude goes to Dr. Kiran Angra for giving all of us this wonderful opportunity to organize such an important faculty development program under Paramarsh scheme of UGC. It is my proud privilege to introduce speaker of the day, Dr. Jatinder Kumar Pradhan, who is an environmental microbiologist having more than 10 years of experience in the field of e-waste, biomineralization research and environmental impact assessment of e-waste management. He has done his MSc and MPhil in life sciences with specialization in microbiology from School of Life Sciences, Sambalpur University, Odisha, followed by PhD in biotechnology from JP University, Shimla. His doctoral topic was impact assessment and development of bioleaching strategy for sustainable management of electronic waste in India. Currently, he is working as an assistant professor in zoology at Kalhandi University, Odisha. He is the principal investigator of M.D.S.D support project on e-waste and biomineralization outcomes. He is dynamically engrossed himself in many studies, assessments, and researches on remediation of hazardous waste and recycling of valuable metals from solid waste using bioleaching strategy and environmental microbiology. He has published more than 20 articles, book chapters, and journal articles in peer-reviewed international national journals, edited books, magazines, and conference series. He is an individual life member of Indian Science Congress Association, National Solid Waste Association of India, and Microbiology Society of India. Sir, we are very delighted to have you with us, and dais is yours. You can start now.
Thank you, madam. Kindly make me a co-host by which I can share my slide.
Sir, 1 minute. You can, I have made you co-host, sir.
Okay.
Just tell me, are you able to share your slides?
Is it visible now?
Yes, sir, we are able to visible your slides, and I request participants kindly switch on your camera for a few minutes so that we can have a photograph with the resource person. Jatin, you have to unmute yourself once, as I have hard muted everyone so that there should not be any disturbance.
So shall I start?
Yes, sir, you can start. We are
Okay.
able to see your slides.
Just okay. So very good afternoon to all of you. Honorable Principal, the coordinator of Faculty Development Program, other faculty members of the same college, Dr. Anuradha Madam, and other delegates who joined on this program from different disciplines. So right now I'm going to speak about a topic which is not much interested, but this is the outcome of the digital India or digital world. So this photograph shows the G7 leaders photograph, that is Boris Johnson's to Joe Biden. So these are the photographs and these are the sculptures made by the Electronic Waste. And this is recently one sculpturist prepared in G7 meeting where all the global leaders, powerful leaders met for a discussion about the development. So at that time, extractivists also demonstrate in this way that this is the outcome of electronic items that we are using in near future. So let me introduce this topic is biomining, an advanced strategy for e-waste management. As Madam already introduced to you about me, I was working in as an environmental microbiologist. At the same time, I also worked on this topic, that is electronic waste. So my field is microbiologist and I am working on electronic waste. So let's discuss how these electronic waste are important for this society right now. So let me introduce what is the definition of electronic waste. So electronic waste are any electrical and electronic items or equipments that have a circuit in the form of electricity and that have some battery supply. So electronic waste become a part of the unused electronic item. You can't say any item or any equipment that is working, that's not waste. But when the user ends is using the electronic items, that we call as electronic waste. So this is also, we all having some electronic items in our home. And recently, during this pandemic situations, we all acquainted with many electronic gadgets. So these electronic items classified into 6 groups. One is temperature exchange equipment, screen and monitors, lamps, large equipments, small IT, and telecommunication equipments. So we all are come across with electronic items that are having electronic waste. So let's discuss why this is an important right now. The volume actually gives an alarming situation to manage electronic waste. Just see, this slide shows that in 2014, the global electronic waste was 44.4 metric ton. That means we have 6.4 kg per capita of electronic waste. And gradually in 2019, it was 53.6 metric ton, and the per capita electronic waste was 7.3 kilograms. So within 5 years, there's a growth of 9.2 metric tons. So it was also expecting that the global electronic waste will be 74.7 metric ton, and the per capita of electronic items is 9 kg per capita. But the story starts here, why you are bothering about electronic waste. So electronic waste, that whatever generated till now, only out of 18% of this electronic waste is being recycled or managed. Rest 83% or 83%, they are going to this environment, which causes different problems. So how these are some importance and how these are harmful, let's discuss about these things. So this much of electronic waste, why? What are the reasons behind it? Why we are suffering? Why our earth is taking some such type of burdens to accommodate some unnatural or chemical hazards, that is electronic waste? Because the population is growing geometrically. Most probably during this period, in the last 10 years, most of the population are tending towards the urban areas. So on urban areas, most of the people we are using many electronic items or equipments. So increasing population as well as increasing demand and increasing the urbanizations, it definitely gives rise to more amount of electronic waste. At the same time, just imagine when 60 years before, there's a land phone. Okay, right now, within last 10 to 20 years, after the evolution of the mobile phones, there is a variety of smartphones. Right now we are having, and maximum we are using the smartphones for 2 to 3 years. So the life expectancy for any electronic items is being reduced because there is a high and rapid technology advancement. Every day there is technology development that we are using that technology for our luxury or for our benefits or for getting any type of advancement or any type of benefits in government policies too. So the proactive entrepreneurial efforts, business strategy, rapid technology advancement, rapid improvement in consumer products and manufacturing processes, affordable systems, and short lifespan of electronic products that give rise to this much of electronic waste. Just example, I'm giving one thing, everything during this pandemic, UGC floated many online courses. So for that courses, every students or every government, every state's government, they run the schools, colleges, all the government offices through the mobiles or laptop. So the purchasing capacity and the availability of the resources in different forms that being changed from time to time. So in this regard, electronic waste amount is increasing day by day. So let's discuss about why we are bothering about electronic waste. As we all have a little bit idea about, although all are not from science background, still all are have a little idea about any electronic items that needs an electric circuits. So for electric circuits, there's a need of conductors. So for making conductors, there are different kinds of elements or different kinds of metals that can be used for making any electronic item. So here I am showing one figure, that is the periodic table, that is in chemistry periodic table. That we are assuming these are this 105 number of elements that we have in earth crust, and that is the source of every kinds of reactions. That is the source of every type of equipment that we are using in our homes. So electronic item by electronic products is a very complex, elemental complex compound which having many precious and critical and non-critical elements. So while I'm talking about the precious, that means electronic items having silver, gold, palladium, iridium, platinum, rubidium, and other base metals like aluminum, iron, copper, and many more. So on this regard, when we look at towards the electronic waste, when we are going to dispose or recycle it, we can recover these precious metals and precious metals and base metals. Then why will recover these base metals or precious metals? Because these are these elements that we are harboring from our natural resources. So as we all have a little bit of idea about the natural resources are not non-renewable resources. So as these are non-renewable resources, so as the population is increasing and the demand is increasing, so we need more natural resources. As more natural resources we need right now, we have to think about the conservation point of view, how to manage the electronic waste to recycle these metals that may be precious or base metals, or there's some hazardous metals too. So in short, I can say electronic waste is a heterogeneous complex material which having rare earth metals, precious metals, hazardous heavy metals, halogenated compounds. So let me discuss one by one the rare earth metals for which all world is trying to get all the rare earth metals. If you are thinking about the nuclear power, there is a rare earth metals we are using for the nuclear powers. So right now, the generation of power from rare earth metals, that is a new advancement in the generation of power, where all the leaders, all the countries are trying to get the rare earth metals, but the concentration in the earth is very low. At the same time, I already told you about the precious metals. Besides precious metals, there are some hazardous heavy metals like mercury and chromium, selenium. These are hazardous metals that is present in the electronic waste. Then come to the halogenated compounds. There is a chlorinated, brominated, or fluorinated halogen compounds will found in the plastics of the electronic waste. So in this regard, electronic waste is not simply a single type of material. It's a mixture of different types of metals. That's why it's a heterogeneous complex materials. So how we'll manage this electronic waste right now? As right now we discussed about what is electronic waste and what is its importance, why you are thinking. But right now we'll discuss how we'll manage the electronic waste. So electronic waste actually basically managed in different ways. But right now, there's a lack of awareness. The electronic waste are not managed properly. And whatever the electronic waste that is generated, either they will be formally collected, that is one possibility. Second one is e-waste in e-waste bins, or e-waste collected outside from formal sectors, and e-waste collected from outside formal sectors in countries with non-developed e-waste management infrastructure. So in this regard, I will say one example. Whatever the electronic waste is generated in related to Indian country, the amount of electronic waste that is not recorded anywhere. So that is the biggest problem. So how we are managing right now? Most probably in Indian countries or developing countries, the electronic waste is managed in informal manner. So informal manner means there's no sustainable technology or techniques that you'll use for the recovery or recycling of electronic waste, for which we are also suffering. So right now, the developed countries, they manage their electronic waste by different sustainable technology. But in India, we don't have any sustainable technology still now to manage all these things. So besides that, there's a transboundary movement happening every day. Means developed countries, their transboundary movements, their electronic waste is transboundary movement to the underdeveloped countries where there is no sustainable technology available. So the people use the electronic items. If they found there is not running the electronic items, they just extract some metals without any knowledges. So by which we'll discuss how we are managing these things. So then come to the what is the impact of the electronic waste, how it's a impact on us, and why you are thinking about it. One aspect I told you, there is a precious metals that we can recover because the natural resource is limited, so we can conserve our natural resources. The second thing is, because of there is informal management in underdeveloped and developed countries where electronic waste either they burn or landfill. And if they are recycled, these also they recycle by acid digestion, low technology recycling, where they use acids and they will burn the electronic items, and they use different types of chemicals to extract metals, and they, after the extraction of metals, they discarded the effluents to the environment, by which the environment is contaminated in all the forms. The soil is also contaminated, the water is contaminated. Besides that, whatever the fumes that generated during the burning of the electronic items, that affect every parts of human beings. So there is a difficulties of the workers. They can also face the health problems, those who are working in the recycling, informal recycling unit of electronic waste. So besides, they have a valuable metals. At the same time, due to heterogeneous nature of the electronic waste, when they burn, they are acid digested. They form different genotoxic compounds. So genotoxic compounds means our earth having a power with the natural components or natural materials that can be biodegraded by the action of microorganisms, some beneficial microorganisms, but the xenobiotic or geno compounds that produced from the electronic waste that cannot be degraded by the microorganism, because these are generated by combination of different chemicals, by which the nature does not have that much of power to adapt immediately to biodegrade the effluents or the materials that release from the electronic waste. So in both of point of view, when I'm thinking about the precious metals, and at the same time, if we will manage it informally, there's a chance of environmental hazards. So in both of point of view, e-waste management is most important part of the nowadays population. So you have to think about the electronic waste management. So let me discuss how these people are. These photographs I have shown you, this is from Delhi. I visited Delhi and I had surveyed on electronic waste management in Delhi area. So basically the people dismantle the electronic waste. See the picture shows there's a dismantling of electronic items. They just separated and segregated the useful parts from different electronic items. After that, they start different processes for the extraction of metals. So these are the open burnings of printed circuit boards of computers or motherboards. And this is an acid bath where they use hydrochloric acid and HNO3 for the extraction of metals. And there is a CRT cycle. Right now, we are not using CRT, but these are cathode ray tubes that are used in the TV, so televisions, where a good amount of mercury is there. So when mercury having high density than other metals, and mercury is very much hazardous to soil as well as water. So because of the mercury contamination, there's also a problem happened in Japan that we call as Minamata disease. Mercury affects the nervous system of human being, and by which there is a problem or disease can occur with the nervous tissues. So these are the ways they followed, and see such amount of there is effluent from the recycling unit where the soils receiving the acids in different forms, and that acids are very toxic. Those acids, they can be penetrate into the groundwater, and the groundwater can also be polluted. So these are some pictures I have collected from the waste recycling units from Delhi. Then discuss how this can be a circular economy. So nowadays we all are thinking about the circular economy as many states, cities. There is a concept that is smart city, where it's a in smart city concept, government advised, okay, we have to think about the waste management to make money. So this is the circular economy. So one product can be circled in such a way in every stage there can be, we can generate money or we can generate revenue. So in circular economy, well, I'm discussing about the circular, whatever in 2019, I said 53.6 metric ton of electronic waste items. So its cost is about to 57 billion US dollars. Okay, so where we'll find approximately 0.2 million tons of kilotons of the gold, and 1 kilotons of the silver, 30.46 kilotons of aluminum, and 20.46 kilotons of the iron. All are the components. Amount may be $57 billion. As I already discussed, only 17% of these electronic items we are able to recycling. So that is around 25 metric tons that is recycled. But if we'll manage, we can save 57 billion US dollars. So simple see this, if we'll go for ideal 100% of recycling, so we can get 39 metric tons of the metals. So, and for 39 tons of the metals from the electronic waste, that is that conserve many electricity, that conserve high amount of water. Why? Because when we are extracting any metals from the ores, natural ores, it needs a vigorous experimental and technological development where there's a good amount of electricity and water used. So for the production of the 39 metric tons of the electronic items, that is 39 metric tons of the metals. So if you will go for using the electronic as a ore, so there is a less amount, we can conserve energy in different forms. So besides that, when we will conserve the energy in that form, also will get money. So electronic waste is more treasure than trash. So today almost all elements of periodic table that are used for making electronic goods and presence of hazardous elements and precious metals in electronic waste makes a prominent source of environmental problems and opportunities. So these are the two things when we're thinking about the electronic waste. And e-waste, right now we are considering it as artificial ore. So e-waste is a complex mixture of base metals, precious metals, and halogenated and combustible plastics that are toxic. So because of the presence of the precious metals and the precious metals are in the form of virgin ores, that's why we call it as artificial ore, or sometimes we are also calling it as urban ore or urban mine. So I will just giving one example where you will understood about the importance of the electronic waste. And the fact is that the electronic waste having 320 tons of gold and 7,500 tons of silver that are usually used for the making of personal computers, mobile phones, tablets, and other electronic goods, and that is worth of 21 billion of dollars of precious metals, and that is eventually available through urban mining of electronic waste. So every year, simple you can see, every year we are using around 320 tons of gold for the making of electronic items. Simple imagine after 3 years or 4 years, if 320 tons of gold will be discarded without knowing its value, then one day the gold will be also act as a rare earth metals. So for this point of view, when we are losing our natural resources by throwing or without any technology for the recycling, so we have to think about the electronic waste management. So urban mining, what is urban mining? And urban mining is a concept and approach for upkeeping the environment and ensuring the advancement of resource conservation through 3R: reuse, recycling, and recovery of valuable and precious materials from electronic waste. So this is the basic mantra for the sustainable development of any technology, that is the 3R policy: reuse, recycle, and recovery. So nowadays, the government formulated some laws that is imposed for the companies, those who are producing the electronic items, that is the extended production responsibility, or we call it as EPR, where the companies will take their responsibility for managing the electronic waste. If you go through the some leaflets that when you will purchase any mobile phones or any goods related to electronic items, you will see there they are giving one contact details to give the return back after your use if you are thinking to dispose any electronic items. So this is extended responsibility of the producers that is imposing right now government, but let's see how it will be implemented. Then So then come to the circular economy, that's the sustainable developmental goals. So as I already told you about the smart cities or sustainable and eco-friendly urban mining of valuable and precious metals of hazardous metals, where we are thinking about some goals, and there's a specific item that is a clean water and sanitation, that is target 3.9. Then third one, say 8th point, you'll find there's a decent work and economic growth. And 11th point, where is sustainable cities and communities. And 12 is responsible consumption and production. So in this regard, there is a concept is sustainable and resilient environment, reduced greenhouse gas emissions, and reduced carbon emissions. So when we are thinking about the reduced greenhouse gas emissions, reduced carbon emissions, and sustainable and resilient environment, we have to think about the recycling of any waste. So, and this is the waste is geometrically it is increasing day by day as our demands are increasing, and we are very much acquainted with the electronic items. So it's need to be recycled, and that is the why you will recycle, because of the resource conservation and enhanced economic value, and formalizing informal sectors, enable skill enhancement and training programs, and eliminate and reduction of hazardous substances, product design for environment and environmental sustainable producers for the resources and recovery, health and safety and active communities engagement. So recently, the many scientists are working on development of the products that are having the less amount of that will require the less amount of metals, and that require very less amount of technology or techniques for its recycling. That's why still we are working on this field, that is called as green technology for the production of green products, green e-products, green electronic products. So right now, I will just give one example citing how we will go for mining the precious metals from electronic waste. As I already discussed with you, the why e-waste for mining. So because e-waste having potential to reduce the extraction of virgin ores, thus extending the life of those resources. The second one is the environmental impacts for metal productions that reduced sustainable when recycled metals rather than primary metals are used. So recycling a metal is generally much more energy efficient than acquiring it from a mine, as already discussed with you. And depending on the metal, on the form of scrap, recycling can save as much as factor of 10 or 20 in energy consumption. So e-waste deposits 40 to 50 times precious metals more than ores mined from the ground. So because of this beneficial point of view, electronic waste, we are thinking for its mining. So mining means extraction of the metals from ore. So here ore is electronic waste. So because this electronic waste having virgin metals. So how we are extracting metals? Still, there are many conventional technology available. Although in India, there is no specific conventional technology are using for the recovery of metals from electronic waste, but there are some countries, they having conventional technologies for recovery of metals like Belgium. So the conventional technology is simply, that is the e-waste that will go for treating with pre-treatment. Simple, there is a manual disassemble and segregated of different components of electronic waste, then processing and concentration. Then there is different chemical and physical methods that we can apply for the separation of different metals from the electronic waste. Like they can be go for the magnetic and electrostatic separations. And there is some one to two example I will give you, that is hydrometallurgical processes and pyrometallurgical processes. These two are more used for the extraction of metals from the electronic waste. So the hydrometallurgical process, where we are using acids, different strong acids for the extraction or dissolution of the metals. So in this simple concept, I can say we'll just trying to soluble the metals that is present in the electronic waste by the application of strong acids. So what will happen when the metal will dissolve in the strong acid, then we'll go for extracting it by the precipitation method, and the rest acids will be thrown out as effluent. So there's a problems also with here. We can extract metals, but at the same time, we can also producing some effluents that can pollute soils and waters. So that's why hydrometallurgical process is also having benefit at the same time. This is also having some disadvantages. Then another technology that we are using nowadays, that is pyrometallurgical processes. So in pyrometallurgical processing, we just simply give the heat, high heat, and we melt the metals from the electronic waste, and we extracted it. So in pyrometallurgical processes, what is happening after applying the heat, whatever the plastic components or other components that present in the electronic waste, that burn and they forms different types of toxic pollutants. So the toxic pollutants like brominated and chlorinated dibenzofurans and dioxins. When the people will inhale this type of toxics, they may face many problems related to the respiratory system, related to the nervous system, or related to the digestive system too. So the toxicity of reagents that used in hydrometallurgical processes and the byproducts of the pyrometallurgical processes that always gives us attention for the another cause, that is the environmental pollution during the process of the recycling of metals from electronic waste. At the same time, the hydrometallurgical process and pyrometallurgical process, these are high cost and energy intensive operations. So considering all these problems in the conventional technology, so technology always need for the development, but technology is an obligatory requirement for the development. So conventional technology we are using, and that is need for us. Still, we are facing the problem. There is a byproducts or some toxic airs that can be released from the pyrometallurgical and hydrometallurgical process. So that's why we are thinking about the alternative technology. So alternative technology, this is not new, but we are trying to implement this technology in the field of recycling of electronic waste. So how we are discussing about how we'll develop a technology. Technology is always inclusiveness, and it's solving mystery of the nature. That's the meaning of where we have to explore the nature with some basic science knowledges. We develop a technology, and by developing a technology, we have to think about three things. One is conservation of natural resources, preservation of natural landscape, and prevention of pollution, that I already discussed. So during the development of any technology, so we have to take care about the conservation, preservation, and prevention policy, that is CPP, for developing a technology. So here the alternative technology, that is micro, that is the solution. So right now we all are acquainted with the micro. Right now we all know what is viruses, what is the pandemic situation we are facing. At the same time, there are some microorganisms like bacteria. They have also beneficial to us in different forms. As we all human beings having microbes within our gut, within our alimentary canal also. They are beneficial and some are also harmful. So the alternative technology to the conventional technology, that is a microbe application of microbes for the dissolution of the metals from the electronic waste. So I'll not go through a lot about the microbiology, just I'll show you how the technology you can use by using the microbes. So technology, the raw materials, that is the electronic waste. Then we'll apply a technology, whether it's a pyrometallurgical, hydrometallurgical, or right now we are calling it alternative technology, that the bio leaching or bio mining. So we'll get a product. So our target is to recycle or recover heavy metals, plus we'll get some byproducts. So that's a problem to manage the byproducts. So more demand for the product, at the same time exhaustion of raw materials, release of harmful byproducts, pollutants, and deterioration of natural landscape, that insist us to think about the alternative technology, that is the biomining. Okay, and that biomining we are called as green urban mining. So what is green technology? So green technology, the name itself implies that it has a green purpose. So green means conservation, prevention, and preservation. So by green, we do not mean the color. It means mother nature and the environment. Environment is green. So that's why the technology which take care of the earth, that is green technology. And green technology is environmental friendly technology that often involve energy efficiency, recycling, safety and health concerns, renewable resources, and more. So these are the necessate, the alternative to conventional technology. So biomining, what is the nature of the agent? Who can be waste eater? For these two questions, the microorganisms, the bacteria, that can be the answer for the nature of agents, and the bacteria can be eater of the electronic waste. So biomining, that is the term that refers to a collection of biotechnological processes in which microorganisms are used in the recovery of metals from mineral ores, concentrates, and waste materials. So biomining processes use the action of microbes for one of two purposes. What are these two? One, either to convert insoluble metal sulfide to water soluble metal sulfates, or as a pre-treatment processes to open up the structure of the mineral, thereby permitting other chemicals to better penetrate the material and solubilize the desired metal. So here I'll just say the microorganisms that they will mimic the conventional techniques, pyrometallurgical and hydrometallurgical, where our target is to solubilize the insoluble metals that present in the electronic waste. So microbe have different capacity. So I'll not go through all these things. Microbe have different capacities. They interact with the metals and they release some secondary metabolites. And the secondary metabolites, it's or sometimes they use metals as their nutritions. So by which they just solubilize the metals. And here I am just showing, this is a figure of the bacteria. So bacteria can be solubilize or mobilize metals in different forms. One is mobilization, another one is immobilization. So in mobilization, there is a process that is bioleaching, where simply in layman concept, I say the bacteria, they just eat the metals, they use the metals in their respiration, by which they solubilize the metals in, they solubilize the metal by producing different kinds of bioacids, where in case of immobilization, they just trap specific metals on their surface. So during the process of trapping is in different forms: biosubstraction, bioaccumulation, and bioprecipitation. So, and bioreductions. So in this way, they trap the metals from the soluble environment. So microbe solubilize the metal. At the same time, microbe can also precipitate the metals. So that's why there's some benefits of bioleaching. So I'm not going through these things. So first I am giving some examples related to this. So besides bacteria, there are some fungi, there are good number of fungi. They have the capacity for the dissolution of metals from electronic waste. So I'll just give one example about my experiment related to this. So what happens? So there are different kinds of bioleaching experiments. There can be laboratory investigation or they can be industrial leaching. So just I'll tell you one example of the bacteria, that is Pseudomonas fluorescens and Chloromonas violescens. They have the ability to dissolve gold from electronic waste. So how they dissolve gold from the electronic waste? These organisms, the microorganisms, they are present in rhizospheric soils. They have an ability to defend themselves, to protect themselves from other organisms by producing hydrogen cyanide. So simple, this is the natural benefits for them. They adopt the techniques for their defense mechanism. They produce hydrogen cyanide. So hydrogen, as you know, hydrogen cyanide is a highly toxic. Still now, no one knows about its taste because it's highly toxic. These are hydrogen cyanides, whatever they produce during their protection from other bacteria. So we are just trying to mimicking the same system in the for the application of the dissolution of gold from electronic waste. So hydrogen cyanide in natural process, also in conventional process, in hydrometallurgical process, we use hydrogen cyanide for the extraction of gold from the ore. So here the ore is replaced by electronic waste. So hydrogen cyanide will form a complex form with the gold, that is the hydrogen cyanide, and that hydrogen cyanide is soluble in nature. So that is water soluble. So the bacteria, Pseudomonas fluorescens or Chrombacterium violaceum, when they will get the raw materials like gold, they will dissolve the raw materials and golds by the applications of the uh, hydrogen cyanide, and they okay. So let's me conclude. Actually, there's lots of things to speak, but due to time limits, I'll just conclude. Say how this the example just I'm showing you whatever I told right now. So biorecovery of gold from leach liquor. This is a one example I have cited here. This is the processor. This is the processor, and the Chrombacterium violaceum, that's the bacteria. This is the dissolution. You can see these yellow precipitates. Then you will use different kinds of other bacteria for its precipitation. So you can extract the golds from the electronic waste. So right now I would conclude myself that electronic items having different precious metals and base metals, as well as many xenobiotic compounds. If you improperly manage it, it can be hazardous to us. If we'll properly manage, we'll get the natural resources and we can conserve the environment. So in this process, this is the alternative technology that we discussed, that the biomining, whereas there is no capital intensive, it's cost effective and not energy intensive and no pollutions. So that's why we are thinking about the biomining for these purposes. So it's my request to go for the 3R policy, and your neighbors or friends about the electronic, and they can approach the electronic recycling sites to collect the electronic items, and that's the recycling, reduce and reuse. And recently we just published one book, that is e-waste management and procurement of environment, along with the another editor, Dr. Suresh Kumar. And I hope I enlightened a little bit about the electronic waste and make some hour with you. And thank you. Have a nice day.
Okay, thank you,
Over
sir.
to Anuradha, madam.
Yes, sir. Thank you so much, sir, for your kind deliberations. The way you have explained e-waste management, it was quite easy to understand because we are not from science background, but still we have understood that what you wanted to convey to us. I request participants, if there is some question, you can unmute yourself and you can ask question to sir, or you can put your questions in chat box. Any participant, if you want to ask question, you can ask questions directly to sir.
Good afternoon, ma'am.
Yes, good afternoon, Jyoti ma'am.
Good afternoon, ma'am. I'm Jyoti from Pollachi, ma'am. That is Tamil Nadu, ma'am. I would like to clarify a doubt from sir, ma'am.
Yes, ma'am, please.
Sir, you said something about the mercury waste and other things, no, sir?
Yes, ma'am.
Uh, how will be getting the mercury waste there in the campus, and is it based on the lab or other things, or it is generally, sir, shared?
No, the mercury is not present in every electronic items. There's a specific electronic items like halogenited bulbs or cathode
Okay.
ray tubes. So
Okay, Professor.
where there you are using mercury, even if right now if you go to purchase any tube light, right now there's a signature, the company clarified itself, the mercury level is this much. That means
Okay,
there's a
Professor.
specific limit. Beyond that, there's no applications of mercury, but the tube lights are not also recycling. So that's why they can be indirectly or directly they enter into the environment.
Yes. So how we can find out the level, sir? Because for the trade, they will
For
be giving
label,
the percentage.
mercury analysis or mercury quantification is a tedious process actually.
Okay, Professor.
Tedious process, that is a biochemical processes that
Yes, Professor.
most of time we are using different chemicals for the estimation of mercury. But there's
Okay,
a
Professor.
concept, vapor gas chromatography, where we can collect the mercury vapors. After that, we will go for extraction of the mercury, then we go for quantify it.
Okay, Professor. This is the process which is done by the biochemist and other people, those who are undergoing all the
Chemistry
finding
students
out.
or environmental chemistry, they are using
Yes.
the techniques.
Yes, Professor. I too done my PG chemistry, but general chemistry I have done, Professor, and I have done my project with zinc 65, Professor, in agriculture. That is a manure added to maize. What is the level
Effect
and
of
how it is
mercury
affected?
on agriculture.
No, Professor. Just I
Hmm.
have taken the uptake studies of zinc 65 like that. I have taken and I have done, Professor, the gamma radiation and other things just
Okay,
for my
madam.
PG project.
Okay.
So my problem is I am buying a tube light, or as Professor shared something about the mercury content particles or the articles, how I can find out this is harmful, this is harmless.
This is another, actually you are asking about a process actually. First of thing, you are trying to know what is the toxicity effects of elements, any elements.
Yes,
That's
Professor.
the your motto actually. You are giving one example, that is the mercury. How mercury affects, how
Ah,
the toxicity of mercury we can quantify. There are different processes. As I told you right now,
ah,
you can get mercury directly from the market. If you are trying to such type of experiment, you need not to go for quantifying mercury from any tube light. You can take mercury and you can apply that mercury in your experiment. If you think about the experiment to the toxicity to the humans, you have to think about the some cell lines, animal cell lines. You can't
yes,
directly apply the mercury to the humans. So that's why you will take some animal cell lines. There's some institution, they have some animal cell lines. That means if you are thinking, I said right now, I said the mercury affects the nervous system. So we need the cell line that having the nervous system.
no,
So
Professor, not going for that. Sorry to interrupt, Professor.
okay, madam, are you getting my point or not?
Yes, sir, there was some disturbance, sir, in between. Sir, could
Okay.
you please suggest some agency for recycling of waste for doctors, if you know some? Could you suggest some kind of agencies or like that for e-waste management of
Right
doctors?
now, every municipality and every state pollution control board, they are authorizing some state agencies, private agencies, to collect the electronic waste as well as for the management of electronic waste. Right now, are you in Haryana? So I'll go through your state public, your state, and go through your state pollution control board website. You'll get some recycling units in your town. I think there's a e-recycler that is in Ambala, perhaps, as
Right,
per my knowledge. But there's a toxic links and e-parisara. There are many organizations in different cities
right, sir.
right now. So you can choose them.
Thank you so much,
Any
sir.
other?
And if there will be any more question, we'll send you to mail, and definitely we expect that you'll answer all those questions. And
Yes,
if
ma'am.
there will be any question in WhatsApp, WhatsApp group which we have created for this faculty development program, we'll send questions over there. Right?
Okay, madam.
Thank you so much. Now I invite my dear friend, a colleague and IQAC member of M.D.S.D Girls College, Ms. Gondi, for her formal vote of thanks and concluding remarks, as well as summary of 7 days faculty development program. Anchal, over to you.
Thank you, ma'am. Am I audible?
Yes,
Hello?
you are audible.
Okay, thank you. A very good evening to one and all. It's my privilege to propose the vote of thanks as well as the concluding remarks on this online national level FTP on institutional values, vision, and leadership organized by IQAC under the Paramar scheme of UGC for the Mentee Institutes. On behalf of whole M.D.S.D Girls College, I extend a hearty vote of thanks to our today's honorable speaker, Dr. Jatendra Kumar Pradhan, who has spared his valuable time to grace the occasion. Participants, sir has accepted our invitation on very short notice as we had session from some other speaker, but because due to her meeting, she couldn't join us. So thank you so much, sir. Today, we had the opportunity to hear your thought-provoking address on e-waste management that has enlightened our mind and have shown us a new path to manage e-waste. And you have also shared how it can be a potential in the circular economy. Now, throughout this 1 week FTP, we have learned various aspects to get higher grades in NET. On the very first day, we had session on best practices by Dr. Namita Rajput, followed by session on green audit by Dr. Anuradha Jain on day 2. And on the third day, we had session on human values and ethics. And on the day 4th, we have session on research design by Dr. Anil Kumar Yadav. And on the 5th day, we had session on academic audit by Dr. Anuradha Jain. And on today, we had session on e-waste management by Dr. Jatendra Kumar Pradhan himself. I am sure that the participants have grasped everything from these sessions and will implement their knowledge in their parent institutes to get higher NAC grades. I am immensely thankful to our respected Principal Ma'am, Dr. Kiran Angra, Assessment and Accreditation Ambassador Paramarsh. Her exemplary vision is the foundation of today's event. My sincere gratitude goes to our organizing team, Dr. Anuradha and Mrs. Nishu Bansal, for their hard work and dedication. A special thanks to all the participants whose sincere and active participation has made this program more successful. Thank you, everyone, and have a very nice day ahead. Over to you, Anuradha, ma'am.
Thank you so much, Anchal, for your concluding remarks and summarization of 7-day faculty development program organized under the umbrella of Paramarsh scheme of UGC. Now I request you kindly send feedback link in chat box so that people can get their certificates. Dear participants, we are really very thankful that you have been with us, and that too for 2 times, 10 in the morning and 3 in the evening. And I am really very thankful to you. Thank you, Nishu ma'am, and thank you, Jatin sir, for making this day more special. And being a art student, I hardly know about e-waste management, but still you have explained it so well. And the way you have told us that we should procure it are really amazing. Thank you so much, sir. And the meeting is open for next 10 to 15 minutes. Till then, you can fill your feedback form. And in case you have any query or any question related to any of the topic, you can put the same in chat box or in WhatsApp group, or directly to me, either to me or to Nishu ma'am. We'll definitely try to resolve as many queries as possible. Thank you so much for everything. And dais is open. If any one of you want to say something or give feedback, you are most welcome. आप में से अगर कोई फीडबैक देना चाहता है तो आप दे सकते हैं. यू कैन अनम्यूट योरसेल्फ or you can fill the feedback form, and after that you can leave the meeting. Thank you so much.
अनुराधा मैडम नमस्कार, मैं रश्मि गौतम हूँ. बहुत अच्छा आपका ये FDV प्रोग्राम रहा और वेबिनार सीरीज रहा, क्योंकि बहुत सारा सब्जेक्ट की नॉलेज मिली और डिफरेंट टॉपिक आपने हर दिन हर सेशन में बल्कि अलग अलग टॉपिक रखे. उस टॉपिक से हम लोगों को, जो मैं तो मीडिया एजुकेटर हूँ, तो मुझे भी काफी कुछ सीखने को मिला. जैसे कि जो डिजाइनिंग की बात है, डिजाइनिंग के लिए कैसे आपको कौन से लॉ की जरूरत होती, क्या चीजें आपको ध्यान में रखनी चाहिए. इसी तरीके से जो है अभी नैक का हर जगह चल रहा, हर एक यूनिवर्सिटी में, तो डाटा मैनेजमेंट कैसे करना है. अभी एक आपने ग्रीन जो है ई वेस्ट जो मैनेजमेंट की बात की है, तो जो भी हमारा वेस्ट मटेरियल है उसको कैसे हम मैनेजमेंट करें और रिसाइकलिंग करें और क्या इफेक्ट पड़ेगा इसका, ये सब चीजें भी अभी आपने इस सेशन में बताई. तो मुझे लगता है कि मैंने 1 वीक का जो है FDP प्रोग्राम में बहुत कुछ सीखा है. शायद और लोगों ने भी बहुत कुछ सीखा होगा, और स्टूडेंट के लिए भी बेनिफिट है और फैकल्टी के लिए भी काफी बेनिफिट है, क्योंकि हम लोगों की नीड भी अभी थी इस टाइप के प्रोग्राम की. जैसे डेटा मैनेजमेंट है और भी अदर सब्जेक्ट हैं, उन सब के बारे में जानकारी की. थैंक यू सो मच मैम, आप और किरण मैडम और जो भी आपकी टीम है, सभी लोगों के लिए थैंक यू सो मच.
थैंक यू सो मच मैम, आपने इतने अच्छे वर्ड्स बोले, इतने मोटिवेटिंग वर्ड्स बोले, और इसके लिए आई एम रियली वेरी थैंकफुल टू यू. एंड यस, there is a team behind every event. Some are behind the camera, some are in front of the cameras, and and of course, no event can be accomplished without a hardworking team. Thank you so much, ma'am.
मैम आपसे 2 साल से जुड़ी हूँ, तब से आपका कोई भी इवेंट मैं छोड़ती नहीं हूँ, अटेंड करती हूँ, क्योंकि जो महिलाओं को या विमेंस को जो हम लोगों को सपोर्ट एक दूसरे का चाहिए, वो बहुत जरूरी है, तभी हम लोग आगे बढ़ते हैं। तो ये भी एक हमारी अप्रोच है, जहाँ पर भी मौका मिलता है तो आपका जरूर हम प्रोग्राम अटेंड करते हैं। थैंक यू सो मच मैम। ओके मैम,
बहुत बहुत धन्यवाद मैम। ये
Okay,
सुन के और भी अच्छा लगा कि हाँ, मैं आपको ऑलमोस्ट अपने एवरी प्रोग्राम में मैं आपको देखती हूँ मैम। मुझे बहुत अच्छा लगता है जब सेम लोग जुड़ रहे हैं, तो इट मीन्स वी आर डूइंग समथिंग गुड।
जी जी,
थैंक यू मैम।
थैंक यू।
Any other participant, if you want to say something, you can unmute yourself and you can switch on your cameras, and it will be good for us. Though meeting has ended and feedback link has been shared, still if you want to say something, it will be good for us. Thank you, Shelly ma'am, for your wonderful comments. Thank you, Kuldeep sir, and thank you everyone.